much time would it take you to write that?
A long time, because I would have to familiarize. You would start with an existing app, and the I can't even remember what it's called now. There's a KDE app that seems closest to this app that I use in class, and it would really just be getting in there and trying to make the Wacom drivers work with this KDE app, and yeah, too long, not worth it. I've got this. Bad attitude, I know. What are we going to do today? It was a rhetorical question. So, here's the syllabus. I added a link to the class webpage down here in class examples. I'll try to be organized. For example, these are two things I'm going to talk about today: strings and broken strings. And let's go to the syllabus. I've added some reading from Savage 11.4, and I've added the homework, and this one truly is due on February 4th. I can envision almost no circumstances where it will be pushed back. Let's have a look at it really briefly. It's fairly short. I'm asking you to write your own stack class, but use my interface again. So stack.h is here. I've already written it. And what I'm going to do is just, your job is fairly straightforward. You're going to write a main program that opens a file of integers, pushes everything onto the stack, and then just pulls everything off the stack. And that's an easy way of reversing a list if you're interested in that. So it'll take all the numbers in the list, you push them all on, you pull them all off, and they're reversed. That does not test everything about this class that I want you to do. In particular, that little demo program is not going to show me that these three things work. So I will have a test suite that I'm going to link to that will make sure that all of those things also work. If I get it written in time, I'll share it with you. But if not, just keep in mind that you've got to make sure that your copy constructor, your destructor, and your assignment operator overloads are all working.
Is there a good way to test if the destructor works?
The easiest way to test, and there's not a super firm way of testing it, but the easiest way to test is just to put little debugging statements in there, like right at the delete command, to convince yourself that your delete command is actually running. And that's really it. And then when the thing passes out of scope, so that's a little bit tricky too. You've got to force your object to pass out of scope while your program is still running. And so the best way to test a destructor in the ways that I'm describing would be to write a simple function that declares your object locally, and then you call the function in the main program. It's gonna allocate that memory when it runs the function, and then when the function ends, it's going to deallocate the memory because that local variable will pass out of scope. We'll talk much more about this in the next day and a half. So this is your job for the week, to write a stack class. Next week, what we're going to do is use that stack class to evaluate expressions. Okay, it's pretty cool. Let me show you. So last time we talked about how if you have a program that allocates and deallocates memory, in particular if it allocates memory, then suddenly you have to take over the job of assignment operator and making copies. You have to show C++ how to make copies of your objects because the default behavior won't suffice. And to show that, I've written a couple of toy classes here, a couple of toy string classes. So let me pull up my toy string class and show you how it works with an eye towards demonstrating why, in particular, we need an assignment operator overload and a copy constructor. The destructor, I'm not going to be able to really illustrate that to you. You just have to take my word for it. So here's a very simple string class. Remember, a string is just a collection of characters. My string class is going to be stored in an array of characters, which I'm going to attach to this pointer right here. Another thing in here is the size, the current number of characters in the array. And then a third thing in here is the currently allocated size of the character array. So let me explain how my guy is going to work. I'm going to start off in my default constructor, and I'm going to allocate a 5-element character array, just to start off with. And I've got these two member functions, well, really just one member function that can actually put stuff in the string. It's called append. Again, this is a toy class. It's just going to take a character and tack it onto the end of my string, one at a time. Really simple. What happens when I get more than 5 characters when I want to add the 6th character? Well, my program, my class objects are going to detect that, and they're going to quickly reallocate memory. They're going to take that 5-element array. Okay, they're going to allocate a 10-element array, copy the 5-element array into the 10-element array, and then delete the 5-element array. So if it gets to the point where I need more than 5 characters, built into my class is going to be a growing of the array. To do this growing requires me to have dynamic memory allocation. You can't do this with a static array. So that's why this is a dynamic class. And why we need the big 3, the assignment operator overload, the copy constructor, and the destructor. So let me get into my, so you'll notice I don't have those in this. I have the default constructor, I have append, I have replace, I have print just so that I can see what's in the string at any particular time, and these guys. Let's go look at my implementation. And we'll go through each of these in turn. So the default constructor goes out and it allocates a 5-character array using the new operator, and it attaches it to the pointer s, which is a member of the class, which is in the private section of the class. Sets the size equal to 0 and the capacity equal to 5. I have this append function. This append function is fairly complicated because this is the guy that's responsible for knowing when to grow the array. So let's see how it works. I get down here and I say, okay, size is the current number of characters in the array. If size plus 1 is more than the capacity, we have to grow the array in order to add this guy. So at this point, we haven't actually added the character to the array. We've detected using this if statement that it needs to grow. So I'm going to grow it. So the allocated capacity was 5. I'm choosing to increment my capacity by 5 characters at a time. So the array, the string might start out with 5 characters capacity, and then it'll jump to 10, 15, 20. So it's always going to jump in increments of 5. That doesn't mean, however, that there are always 10 characters or 15 characters, right? There's some number between 0 and the maximum capacity of characters in there. So here I grow the capacity because this is an important number. This lets me know when I might have to grow it again. I get myself a new array, which I've attached to this temporary character pointer. So if the original capacity was 5, at this point it becomes 10, and now I've allocated 10 new characters in an array, and they're attached to this temp pointer. Now I'm going to copy the stuff out of the old array, S, into the new array. Now I'm going to delete the old array, and I'm going to point S at the new array. It's a fairly standard recipe for reallocating an array.
Why do you have the brackets before delete?
That's a signal to delete that this pointer is pointing to an array. So if you just do delete without those things, it'll just delete the thing right at the front of the array, and then it'll leave the rest of it there. It might even just throw an error, I don't know, but that's the syntax. Go ahead, Jamie.
So is it just like literally dereferencing and getting rid of those memories?
Returning the memory to the system.
Okay.
Yep. Right, because before that delete, I've got the 10 characters in the new array, and I've got the 5 characters in the old array. And I want to throw away the old array. I don't want to have a leak. So here's yet another place where you could have a leak. If you forgot to delete the old array and you just moved temp to S and you didn't have this delete thing, it would still work. Your strings would still grow. Everything would be lovely, but you'd be leaking memory every time an array grew. Once you've grown the array, you can tack on the character. And notice that this statement is outside the if statement. By the time I get here, either I've grown the array to accommodate the new character, or I didn't need to grow the array in the first place, in which case it can accommodate the character. And then I increment size. Have you guys seen this before? So S size plus plus. When you have the plus plus after the variable, it reads the value of the variable first, and then it increments it. And if you switch it around, which I don't want to do here, but if I do something like this, it'll increment it and then read it. So perhaps a slightly clearer way to do this would be something like that. So I take the character and I add it into the next open slot, which is S size, and then I increment size to note that I've actually added a character to the string. So I'll leave it like this. Replace is pretty straightforward, and this is one that the user of the class has to be careful. So I didn't put any bounds checking in here or anything like that. I'm just, again, this is a toy class. I want to be able to take a character and insert it not insert it, excuse me, but replace an existing character with a character of my choice. And that's for the purposes of demonstrating how this broken strings class fails. Print string just goes through the array and prints out the characters. So for I equals 0 up to size -1, print out SI. Everybody okay with that? Good. Let me go in and show you my main and show you how I'm going to make this fail.
If you tried to replace something that wasn't allocated to the string, it would throw a segmentation fault.
If I was within range of the currently allocated space, it would be fine. But yeah, you're right. If I tried to, like, let's say the current capacity was 5, and then I used replace C7, I risk a segmentation fault because I'm trying to write to memory that I don't technically own.
Or it might just let it go.
It will sometimes let it go. And it just depends on what else you've been doing. Did you run Word that morning on your computer or whatever? It really just depends on what the current memory map is on the running machine. Which is why working with memory is so fraught, because something that worked fine yesterday, you open it up and you run it today and it fails with a segmentation fault, and you've literally done nothing except you ran Chrome twice this morning and only once yesterday or something like that. Totally unrelated. Let's go to my main. I'll explain what I'm doing here. I'm allocating 2 of these broken strings, A and B. To begin with, I build A, really simple string, just A and B. I'm going to print out the contents of A, so at this point I should see just a string, capital A, capital B. I'm going to do an assignment, B equals A. Remember, B is the other string and I haven't done anything with it yet. So B equals A. I'm going to print out B, and you're going to see that in fact B is identical to A. Then I'm going to go and I'm going to modify B. So I'm going to replace the second character, the B, with a C. And then I'm going to show you the contents of that. And then I'm going to show you the contents of A. Okay, so let's look at this thing. I build the string, just 2 characters, capital A, capital B. I do the assignment, and then I print out B, and B is, not surprisingly, identical to A. Then I do that insert, or the replace command on B. I replace the B with a C, and I print out B. But remember, I did the replace command on the B object, not the A object. But if I print out the A object, you see that the change has been done to the A object as well. And I talked briefly about this on Friday about why this is true. What happened is the pointers got copied, but the memory didn't get copied. And so now the pointers are both pointing at the same memory location, the same array. And when I made changes to that array through B, those changes are all tangled up with A now. Obviously, being able to copy being able to copy objects in a class that you've built from one object to the other is a desirable thing. And this is clearly not desirable. So how do we get around this? Let me go and show you the non-broken strings version. So this is the identical class, except there are a couple of notable additions here. And in fact, well, yeah, let's just talk about it. So the default constructor is still there. There's a new thing there called a copy constructor. And a copy constructor always looks the same. Its name is the class, and its one argument is a constant string and, or a constant and whatever the name of the class is, ampersand. Seems kind of weird to pass by reference and then put constant in front of it. Why do we do this? Why do we pass by reference, which is usually an indication that we want to allow this thing to be changed by the function? And why would we put the constant keyword in front of it? What this does is it passes the original object into the function, and this is not just true for constructors, it's true for general C++ functions. It passes the original object into the function. With the extra constant keyword in there, it will prevent you from changing that object. It's really just a protective measure for the programmer, so that the programmer doesn't accidentally change this thing that you're passing in. Now, if I don't want to change it, why don't I just do this? Why don't I just pass by value?
Then it copies what you don't want it doing yet.
Right, because it doesn't know how to do that. That's precisely the thing that I'm trying to define, is how to copy, how to pass by value. So you've got this little sort of paradox, right? I can't pass by value because that's precisely the thing I'm trying to define.
Is this what you mean by overloading the constants? When you said in the next assignment, overloading the copy constructor?
The assignment operator. Yeah. We'll get to that in a second. So I will say, however, there are other good reasons other than just this seemingly paradoxical situation for doing constant class ampersand. Constant class ampersand is like passing by value, right? Because there's no risk of changing the incoming object. But what's nice about it is it doesn't make a copy. And if your objects are really massive, like 7 billion element arrays, and you want to pass it by value, don't pass it by value. Do constant object ampersand and pass it in by reference. And with the constant keyword, there's no way that it'll be changed by the function. The other thing is, if you're not sure that the object or the class has a copy constructor, this is a safe way of passing something in, because this will always work. The downside is you're not allowed to change it, and that may be something that you need to do, in which case you need a copy constructor. Okay, the destructor is tasked with deallocating the memory. We'll talk about that later. That's the easiest of these three guys. The most complicated of these three guys is this guy, the assignment operator. So this guy's arguments and return values are also always the same. The return value is a return by reference of the class. Operator equals is what you use to refer to the assignment operator, and then its argument is a constant string ampersand or constant pass by reference object. The way to look at this thing is the argument is the right-hand side of the assignment. And And the left-hand side is somewhat of a mind-bending mystery that I'll discuss. Append, replace, and print are all identical. The character pointer and the size and the capacity are all identical. Let me show you my main program again, and you'll see it's identical to the one that I just showed you, the one that had problems. Except it doesn't have the problem anymore. And that's because a faithful copy of A was created specifically for B, and B now has its own data to work with. Questions about this before I go on? I have not shown you the details of this, but any questions? Okay. I guess the best way to do this is just to talk through. So I strongly encourage you to read both Savage, the stuff that I've recommended in Savage, and Gishard's notes. I put some new notes from Gishard up there on the web page. Let me just show them to you. Chapter 5 is actually a far more complete discussion of this topic than Savage. And these are from Gishard's notes. So I've assigned this reading. Make sure that you read it and understand it. I will talk about this by way of example, and let's go through and look at the implementation of my simple string class. So the default constructor is still there. When you're dealing with dynamic memory in classes, there's a particular order that you want to build these things in. So you have your default constructor, and this guy is called, for example, it's called right up here at the top. So when you declare variables like this, that's the default constructor. We already know about that guy. Let's start with the most complicated one first. So you write the assignment operator overload first, and then you use the assignment operator overload to do the copy constructor, because most of the work that you do in these two, most of the work that you're doing is in creating a copy, a good copy of the object. And there's no reason to duplicate effort. If you do what I'm about to show you here, you can spend all of your time working on the assignment operator, and then the copy constructor is a breeze. So let's talk about how this works, and let's go back to our main program and look at this assignment. So right here we have B equals A. When this happens, you are invoking the equals operation in the object B. So A, in this case, is RHS. A is RHS. The stuff inside A is the same as the stuff inside RHS. Where is B in this picture? B is the implicit object in this function. So, for example, right here, when I delete S, this is the S that's in B, the left-hand side. But we don't have an explicit variable for the left-hand side. It's implicit. All of the class variables that you refer to in here like this are just the left-hand side. On the other hand, if I want to refer to a class variable on the right-hand side, then I use RHS.size or RHS.s, etc. Now, we have to think about a lot of things when we're writing an assignment operator. For example, it might be that the thing you're assigning to, it has some baggage attached with it. It's a pre-existing object. It already has lots of memory allocated to it. It's been used in lots of different circumstances. And then finally it gets up to this point in the program, and you want to copy A into it. Well, the first thing you have to do is get rid of all the baggage that's in the left-hand side. Actually, I'm backing up. I need to back up one step. There's one more thing you have to deal with, and it's kind of stupid, but it does happen. You have to deal with that. This is called self-assignment. This has to work. And the easiest way to deal with that, it's just sort of a recipe. If you really, really, really need to get your hands on the left-hand side object, use this. This keyword is a pointer to the implicit object. So this is the mind-bending part of the lesson. Jamie.
So when you call the operator, so when you do A equals B, you're basically doing a function of A.
B equals A and a function of B in this picture, yes.
Okay.
Yep.
Okay. So yeah. Okay. So then this is the.
This, in this case, this is B.
Yeah.
Or not B, but a pointer at B.
Right.
Okay. So the first check is if this, in other words, if the memory address of B is the same as the memory address of the right-hand side, there is no question that this is the same object because they occupy the same place in memory. That's what that first check does. So if the address, the memory address of the left-hand side is the same as the memory address of the right-hand side, don't do a thing. Just return the object. Okay, because that's the other thing that an assignment operator is supposed to do. It's supposed to return a copy of the right-hand side so that we can do recursive assignments. A equals B equals C equals D will only work if we return a copy of the object. Yes?
Why do you have an ampersand in front of that RHS?
Okay, so this guy comes in, RHS, it comes in as the object, not a pointer to the object, but the object on the right-hand side. This is a pointer to the object. The ampersand gets the address.
Okay. Wait, this is a pointer to.
This is a pointer to the left-hand side. It's a really unfortunate word, isn't it? It's hard to use it in class. Okay. Let's talk about this. What's star this doing?
It's dereferencing.
It's dereferencing, so it's taking the address and turning it back into the actual object. Then it's returning it to the calling function by reference. We're going to talk more about return by reference either today or Wednesday because, in fact, it's going to play a big role in your stack program. Returning by reference. Okay, let's keep going here. So, yeah.
How come you couldn't just do if this equals right-hand side return, just like return?
It has to have a return value of a reference to a string.
Okay.
But I could do this. Let me make sure I get this right. I could do this. And that would be equivalent.
Okay.
Because they're both the same thing at that point. So we get past the if statement, which means that these two guys are different objects. Delete S. Okay, so remember that the left-hand side it has a history. It wasn't a brand new object. Even if it was a brand new object, the default constructor still ran and still attached some memory to S. So the first thing we do is we delete the memory attached to S. If we don't do that, what happens?
The pointer stays the same. The pointer to the first character has.
Well, let's go down here. Look at this line right here. If I don't delete it and I do this, memory leak. Whatever memory was attached to this will not get returned to the system, and when I get to here, that pointer is going to get overwritten by the new memory. All right, so we take care of any baggage, any history that this object on the left-hand side might have. In this case, it really just means deallocating the memory that's associated with that left-hand side object. Now I want a faithful copy of the right-hand side. So the capacity of the left-hand side is going to be the same as the capacity of the right-hand side. Essentially, I'm just copying the class variables. The size of the left-hand side is the same as the size of the right-hand side. Everybody still with me? And the memory attached to the pointer is the same as the memory attached to the pointer on the right-hand side. So these three things kind of duplicate the class memory up to a point. And then this loop here, what's going on here? So I've allocated space in the left-hand side object, but I haven't actually copied the characters yet. So now I'm copying the characters into the left-hand side object. And when I'm done, I return again a copy of the object, because that's what we want with assignment operators, so that we can do recursive assignment. Let's keep going. The copy constructor. So you write the assignment operator, and now you're ready to do the copy constructor, and the copy constructor isn't so bad. Okay, a copy constructor is similar to an assignment operator in the sense that you have the original thing, the thing that you're trying to make a copy of, and then the new thing, that's the copy. The new thing, the copy is going to be the this object, and the original is the thing that you're trying to copy. Everybody got that? Now, when the copy constructor runs, the default constructor does not run. So let's go back and remind ourselves what the default constructor did. The default constructor allocated 5 characters to the pointer s. It set the size equal to 0 and the capacity equal to 5. That, I'll remind you, runs right up here. String A, string B. When you're in the copy constructor, you may not assume that the default constructor is run. So what you have now is an object with a pointer in it that has garbage in it, and a size variable that has garbage in it, and a capacity that has garbage in it. None of those things are reliable. Okay.
Wait, so you're creating the object in the copy constructor?
Yeah, in a sense, I'm creating the object. So that's why this is here. There's a pointer in the new object. That we know. But it hasn't been pointed at anything yet. And that's a problem, and it's a problem that I'll just explain it, and then you can think about it. So you do s equals null. Why do I do this? Well, because then the next thing I do is I use the assignment operator to copy the original to this. Now, this operator right here is this guy up here. So it's actually using that because it's copying an object in this class to another object in this class. The reason I have s equals null is this line right here. If there's junk in that pointer and I try to delete it, I'm going to be attempting to delete memory that I don't own. because that pointer is going to be pointing at some random memory location, and I'm going to be trying to return that back to the heap, and you're going to get a segmentation fault. So what you do is you set s equal to null here so that when you get to here in the assignment operator overload, it's safe. Deleting the null pointer is no problem. C++ lets you delete the null pointer. It doesn't actually do anything, but it lets you do it. But if there's random junk in that variable, when you get to that point, you're going to get a segmentation fault.
But S doesn't even exist yet, right? Or it might, and we...
No, it does exist. It just hasn't been initialized, right? What does it take? There are two things that have to happen when you create one of these objects. Let's go back to...
Just really quick, is that S, would that be the same thing as doing like this dot S?
Yes.
Oh.
Not this dot S, star this dot S, yes.
Okay.
There's a point between the allocation of the space for an object and the constructor. There's a period of time, right? When I allocate one of these objects, I allocate space for a character star pointer, or character pointer, space for an unsigned int, and space for another unsigned int. So the memory footprint of one of these proto objects before it gets to the constructor, the memory footprint is 4 bytes for a pointer, 4 bytes for size, 4 bytes for capacity. So 12 bytes total for this object.
Well, I mean, you say before we get to the constructor.
Right.
We're already in the...
What I'm saying is there's a period of time between the allocation of the memory for these variables and when this constructor runs. Okay, so I allocate the space. I go out and I ask the operating system, give me 4 bytes for this pointer, give me 4 bytes for this size, and give me 4 bytes for capacity. The next thing I do is I run a constructor to initialize those variables. So the memory is there, but the constructor hasn't been run yet. Everybody with me? Okay. Now, depending on the context in which this is happening, for example, if I'm up here, those memory locations are now handled by the default constructor. This guy here. So now that junk pointer is now an actual pointer to some actual characters. The size integer is now an actual integer, 0. And the capacity is actually 5 now. It's not just junk, junk, junk. It's got values in it. The problem with the copy constructor is this guy is responsible now for filling the class variables, because this guy up here is not used, right? Only one constructor runs, and it's not this one, it's this one. So you've got this proto object with these 3 class variables, none of which has been initialized. And your job, frankly, is to initialize them. That's what the constructor does. It initializes the class variables. So I set the pointer to null, and then I do the rest of the initialization with the assignment operator overload. Why do I have to set it to null? Because one of the things that happens in the assignment operator is a delete of the pointer. And if that pointer has junk in it, you're going to get a seg fault. You can read about this in David's book, in David's notes, if you're not totally getting it right now. I get that it's complicated. The whole this thing is really twisted. Okay, let's keep going. So if you write a good assignment operator overload, then your copy constructor becomes pretty simple. Your destructor in this case is pretty simple also. It's really just deleting the memory attached to S. For a linked list, this is more complicated, right? You've probably already realized that, since the stuff that you're supposed to turn in today involved deleting a linked list. You have to traverse the list and delete the nodes as you go along. So deleting can be quite complicated. In this particular toy class, deleting or deallocating is simple. When does a copy constructor run? Did we talk about this last time? I don't know if we did or not.
When you return objects and functions.
Yeah, so I think we did. So when you pass by value, remember when you pass something by value, you don't pass in the original data. You actually make a copy of it, and the function works on a copy of it. How does that copy come into being? C++ automatically invokes the copy constructor to make a faithful copy for the function.
And it just memorizes the syntax used for copy.
Exactly, yes. When you return by value, or when you return an object back, so if I had a function that returned a string, right at the end of that function I would return a string object, right? A copy of that object is actually created at that point and passed back to the main program. And one last sort of weird situation, which we don't often see. I don't use this syntax very much, but some people do. You can, of course, declare a string anywhere, like that, and this will invoke the copy constructor.
Oh, so that's literally use the copy. That's
Right. So if I want to declare and initialize an object of the string class from another object, from an existing object, I can use the copy constructor like this.
Could we also say string C equals A?
String C equals A. Yes. Yes, and it'll invoke the assignment operator overload. Yes. Other questions? Okay. That's good. Let me, I wanted to finish today. I know that I've dumped Vim on you, and I wanted to finish today with just, I'm going to try to at least once a week just talk about Vim for 5 or 6 minutes and some things that you can do in Vim that you probably watched me up here doing. I actually searched, and if somebody can find me a program that will maybe pop up a copy of the keyboard down here and just show what keys I'm hitting on the keyboard. I looked around for something like that and I couldn't find it.
The visual keyboard not do it?
Yeah, I think on
It does not. So I've got this keyboard here, and it doesn't. No.
Oh, well, what about
It
the...
didn't run this.
There's a screen capture program, so they're not cheap for that. And that probably is.
It might. I'll look at that. Maybe that would be because if I could be using Vim and then having the keystrokes show up, then when you're watching the video, you could actually see what keystrokes I'm doing to do various things in Vim, which might be useful. But that said, if somebody finds something like that, please do forward it to me. Dang it. Did not want to do that. Just closed my terminal.
At some point, could you go over multiple buffers at once?
Yeah, okay, I could talk about that today if yeah. I was going to talk about just simple cutting and pasting, but if I get time, I'll talk about multiple buffers too. All right, so if you've got a typo, the quickest way to delete a character is just to put your cursor right on top of it and hit X. And X is like cut in Windows or Mac. I can go somewhere else and put it back with a P. So X is like cut, and that's just sort of accidental that it matches up with Control X from Windows. And P is like put or paste. So X and P are good things to know. It's also really important to be a good Vim user. You have to know where your characters are going to go. So if I'm here and I hit I, then the characters are going to appear before the cursor in a sense, before the E. And that's something that it's really good to just get comfortable with. But let's say I'm at the end of a line, right? And if I hit I, that's not helpful. Let's say I want to put something at the end of the line. There's a complementary command called append, and that will put stuff after your cursor location. So if I'm in the middle here and I want to put text before the N, I hit I. And if I want to put stuff after the N, I put A for after or append. And getting comfortable with that is probably one of the earliest things that will help you with VI. If I hit capital I can start typing at the beginning of a line. And if I hit capital A, I can start typing at the end of a line. That's kind of useful. And again, it kind of meshes with little I and little a. Big I is a line, big A is a line, little I is a character, little a is a character-based sort of thing. Okay, let's suppose that we want to copy a line. There are a couple of different ways, but I'm going to show you a technique that is quite general in Vim and pretty useful. There's this visual mode. If I type V in command mode, you notice in the lower left-hand side it says visual. I can now start moving the cursor around using the HJKL keys, and I'll start a selection. And the selection goes up to and includes the cursor position. If I hit X now, I get a cut, and I can go somewhere else and hit P and paste. And that's true for any selection that I can make. So I turn on visual mode, I hit X, and then I go down here and I hit P. There are other ways of cutting and pasting that I will probably talk about later in the semester, but this visual mode is probably the most powerful. Okay, visual mode. There you go. That was exactly what I wanted to mention. Sometimes you want to copy without cutting, so you can highlight and you can hit Y. And you notice in the lower left-hand corner it says 4 lines yanked. I have no idea why it was 4 lines. I thought it was 3.
If you hit Y and you're not in visual mode, does it just copy the letter you're over?
If you hit Y in visual mode, it's going to wait for you to type Y again.
Wait, you mean in non-visual mode?
In non-visual mode. Right? So if I'm here and I hit YY, I get 1 line. If I'm up here and I hit Y3Y, I get 3 lines. But a lot of people have, their minds just don't work that way. In fact, that's what I usually do. But a lot of people just prefer to highlight the 3 lines and then hit Y and then go down here and hit paste. Okay. Notice all these modifications. I do them and then I undo them. The U key is also quite useful. That's in command mode. I can undo anything.
So why you enter the cursor?
Y doesn't do anything by itself.
Right.
Okay. So YY gets me the line, and Y by itself, nothing. In fact, I'm not sure how to copy a character. I'm sure it's in there, but that's not something that's ever sort of crept into my
YL would probably do it.
You would definitely want to do it because you just type the letter, but I was curious.
Yeah, you can hit, like if I want to replace E right there, I can hit S for substitute. And then I can keep typing. So that's one way of doing it. Or I can hit R, and then I can't keep typing. I'm in command mode. So I can replace it and leave myself in command mode, or I can S it and put myself in insert mode. Again, really subtle stuff, but once you internalize it, it makes you super fast at stuff.
Right now, the easiest way to go from insert mode or visual mode back to command mode is escape.
It's the only way, really. Yes.
Really? That sucks.
Well, there's also control right bracket. Sorry, control right square bracket. Yeah. So if I'm in insert mode and I think it still works. Control. Nope, it doesn't work anymore. Used to work.
Is the other.
I'm guessing you use.
Oh, maybe it's the other one. Yeah, it is. Thank you. Yeah. I never use that.
Is there a way to redo changes after you punch
Yeah,
it out?
so U undoes and Control R redoes. And the reason it's not U and R is because R was used for something else in VI before they thought about the undo redo stack. And so it got sort of poor seconds, Control R instead of R. I think if you had it to do over again, people would have preferred U and R to be complementary, but it just didn't work out that way. Evan.
So for those of us who might be used to auto formatters, it's
Yeah.
kind of a pain in the ass to space out multiple lines equally.
So let me get some of these guys out of sorts here. You can highlight the whole file and hit the equal sign.
Oh my god.
Or you can just highlight a little piece of it, because I think it's smart enough to figure out where it is. So let me just highlight a little piece of it here. Yeah. So it's smart enough to even reach out and figure out what block it's in and indent it correctly.
What's the default indentation on VI?
I don't know what the default is. I have tweaked mine so badly now that I don't even know what I do anymore. I think mine's
Varies
2.
by syntax.
So mine, I've always preferred two character indent in everything that I do, and so I've got my Vim RC.
Oh yeah, I understand.
Somewhere in here.
Set auto indent VS.
It might be this thing right here. It's been so long since I tweaked any of these.
Like preferences, but less nice looking.
Right there at the top is 1999.
No, backspace is that's a different one. No, that 1999 is the last time I decided to put a date up there. I've been using Vim since I think maybe his second major version number. We're in Vim 7. I've been using it since I think Vim 2, which is puts me back around 1992. I've been using Vim. So before Vim there was VI, which was developed by I think Bill Joy, maybe at AT&T. It was the first sort of screen editor ever written. Well, not ever maybe, but certainly an early screen editor. And it has most of the same functionality, but Vim, it had this like syntax highlighting, which VI didn't have. It had this thing, which I just absolutely fell in love with the first time I saw it. And so I quickly left plain vanilla VI behind and went with Vim. And if you look at Ubuntu, they've now switched over to Vim too. So there's not most of the big Unix distributions now use Vim. I don't know where my, you know, it might be in my C++ section.
Yeah.
Pascal's in there. That tells you something right there.
Yeah, shift with 2. There it is.
Oh, where?
Right, third line, fourth line now. Algebra.
Yeah, there it is. Yep, thank you. Yep. Okay. I can share my Vim RC with you if you'd like. Maybe I'll post that somewhere. Last thing for Ben, I know I'm 5 minutes over time. Feel free to take off if you want. So if I'm in this guy and I really want to look at my my string.h or something, I can just hit :E and then string.cpp. I can just keep hitting tab and it'll give me all the things that start with string. So now I'm in there, but that other file is not gone. If I type ls, I can see both buffers, lots of symbols attached to it, but that's okay. If I want to go back to the first buffer, I can either use b pound, which will toggle me between my two most recent buffers, or let me open up another one. Now I've got 3 buffers. And I can use the numbers like B1, B2, B3, and if I don't remember what the numbers are, I can type LS, and it'll tell me, it'll give me a summary of what the buffers are.
Colon LS or just colon LS?
Colon LS, and then colon B2, colon B3, and you should see me when I grade your programs. Like, let's do grading at caret. So this is what it looks like when I'm grading my C++ class. And I just work my way through one buffer at a time. Go to B20 and then LS, and that tells me, so now I can see that I'm at buffer 20. They don't all fit on the same page, so I can page down a little bit and see. It seems crazy, but man, if you take the time to get this, you are untouchable in the editing world. You cannot be beaten. There is no other text editor that can give you this. Not at this level. But it requires a lot up here, right? You have to keep track of stuff up here as well as there. But it's totally worth it. Notice I have a separate account for grading. I don't know if you noticed that. I had to log in as